Welcome back to Summarize Science. Today we're talking about one of the most violent events in the universe, a star being torn apart by a supermassive black hole. This is called a tidal disruption event, or TD, and astronomers study them to learn about black holes and the extreme environments around them. But a recent TD, named at 2018 CQH, has been acting very strangely, and scientists have been working to figure out why. Normally, when a TD happens, the stellar debris thrown outwards crashes into the surrounding gas, creating radio waves. But with at 2018 CQH, the radio emission was delayed for over 1,000 days. When it finally appeared, the signal didn't just get steadily brighter, it had strange bumps and fluctuations, as you can see in this light curve from the study. The standard model, where the debris hits a uniform fog of gas, couldn't explain this bizarre behavior. To get a closer look, astronomers used a network of radio telescopes called the VLBA to zoom in on the event. They found that the radio source was extremely compact, smaller than 0.13 parsecs across. This incredible resolution told them that whatever was generating these radio waves was happening in a very small, specific area. This led researchers to a new hypothesis. What if the environment around this black hole isn't a smooth fog, but is instead clumpy and filled with dense clouds? This is actually plausible because the galaxy hosting this event is known to have an active nucleus, which is often a messy, cloudy place. The idea is that the outflow from the shredded star isn't hitting a smooth wall of gas, but is instead smashing into one of these dense clouds. To test this, the team ran sophisticated hydrodynamic simulations. Here you can see the simulation, showing the outflow from the TD slamming into a dense cloud. This created a powerful bow shock around the cloud. The radio signals predicted by this simulation were a near-perfect match for the strange, evolving signals actually observed from at 2018 CQH. The simulation explains why the radio emission was delayed. The debris had to travel to reach the cloud. It also explains the bumpy light curve, as the outflow interacts with the uneven structure of the cloud. And it solves the mystery of the evolving radio spectrum, showing how the peak brightness shifts as the shockwave wraps around the cloud. So, let's recap the important points. The tidal disruption event at 2018 CQH produced a peculiar radio signal that was delayed, fast-rising, and bumpy. This couldn't be explained by the standard model of an outflow hitting a smooth, uniform medium. Instead, the data and simulations strongly support a new model where the stellar debris is violently colliding with a dense cloud in the black hole's neighborhood. This is a big deal because it gives us a new way to probe the chaotic, clumpy environments right next to supermassive black holes, which are normally impossible to see. In the future, astronomers will continue to watch this event, and they might even detect X-rays generated by this cosmic crash. This work highlights just how dynamic and complex the centers of galaxies can be. Thanks for joining us on Summarize Science. Don't forget to like and subscribe for more deep dives into the latest research.